So in this particular section, what we're going to do is the very important skill of actually solving trig equations. So again, we're going to be trying to find the value of x that makes this equation true. Again, this is significant because usually we've been fine by just saying, that sine x is equal to 1/3. We've been able to do a lot of math, do a lot of trig stuff by just knowing that the output of sine is 1/3 and not really worrying about the angle. But starting in 6.1, and we have done this in the past when we had nice exact values, but definitely in 6.2, we're going to use all our trig knowledge to actually solve a trig equation. We're going to be able to use exact values. There'll be some stretches where we'll turn to our calculator, but definitely have your unit circle knowledge out. And what we're going to do first is take a look at all the different types of trigonometric equations we'll run into, and then we'll wrap things up by taking, kind of a hodgepodge and making some decisions. So just like in college algebra or any algebra, we actually start with what I call the linear form of a trigonometric equation. Usually when we have a linear form, that means that the trig function that we have, as you kind of see here, is only to the first power, all right, and there's no other multiple angles in it. So essentially, it's almost like solving, forget the trig function there, it's almost like solving the square root of 2 minus 1 equals x. Of course, what we did is we used the golden rule, we added and subtracted to get that x all by itself. So we're going to do the same thing here. I'll start by adding 1 to both sides. This gets us the square root of 2 times the sine of x is 1. To get sine x by itself, I'll divide both sides by the square root of 2. And we are now looking at the sine of x is equal to basically positive. This is square root of 2 over 2, the square root of 2 over 2. All right, now we could in fact invoke our inverse sine function here, but remember that's only going to give us one of our values. It's actually going to give us the one we expect in quad 1. But we also know that in a full rotation from 0 to 2 pi, we also get an angle in quad number 2. And so we're going to get two values here. In quad 1, the angle value is pi over 4, or what we know to be 45 degrees if we were working in degree mode. And in quad number 2, our x would be 3 pi over 4, or what we know to be 135 degrees. So again, if we had used the arc sine, right, saying that x is the arc sine of the square root of 2 over 2, we're only going to get that value. But I'm using my knowledge of my sine function to know that there's actually two values. So some previous trig information coming up. But back to the bigger picture, right, this is what we call a trig equation in linear form, because all I have to do is linear equation things, add, subtract, multiply, and divide, the same thing to both sides, to finally get the sine by itself. Once it's by itself, I can invoke my trig understanding. Same thing here. Again, treat this like it was 4x plus 5 equal to 2x plus 6, right? So I would basically add and subtract a bunch of things to get x all by one side and get the non-x stuff to the other. So we're going to do the same thing here, except rather than pulling an x around, we have a cosine x. So I'll start by subtracting 2 cosine x from both sides, and I could be subtracting 5 from both sides. So that gives us 2 cosine x equals 1. Dividing both sides by 2, we get the cosine of x is equal to 1/2. Again, we're positive, so cosine is positive in quad 1, in quad 4. And we're talking about the first full rotation going on. So that's quad 4, by the way. All right, and so what angle makes cosine equal to 1/2? Well, that would be 60 degrees, or what we know to be pi over 3, right? 60 degrees if we were in degree mode. Of course, what's the quad 4 one? Well, would have a 60-degree reference, right? So that would be 300 degrees. But in radian mode, right, that's 5 pi over 3. So there would be our two equations, or excuse me, our two solutions to 4x cosine x plus 5 equals 2 cosine x plus 6. So again, we're just doing linear equation form stuff, golden rule of adding or subtracting things to both sides until I can solve for the function. And then once I have that, I can start using my cosine, my trig knowledge about cosine to figure out the rest. The next order of business, usually when we're teaching algebra after we've done some linear forms, there's quadratic forms, right? So we're talking about ax squared plus bx plus c is equal to 0. Of course, the classic way to solve this is by factoring. If it doesn't factor, we can use the quadratic formula, on and on and on. If you're sadistic, you can complete the square, but we have several different ways that we can solve a quadratic. So that's how we need to see this. We need to see this as the quadratic function it is in terms of sine squared. Again, this is almost like looking at 2a squared minus 1. All right. Oh, also, we have the square root property, which I'm going to invoke here. So this doesn't really factor very well, but if I start adding 1 to both sides, we get that this 2 sine squared x equals 1. Divide everything by 2. We get sine squared x is equal to 1/2. Taking a square root, right, there's my square root property, we have that the sine of x is plus or minus 1 over the square root of 2. So we actually have two potential things we can look at, right? If we rationalize that denominator, by the way, we're looking at the sine of x equals negative square root of 2 over 2, or we're looking at the sine of x equals positive square roots of 2 over 2. So what we have then, right, is basically we have to consider where's sine positive and where's negative, and we know that ratio square root of 2 over 2 gives us a 45-degree reference, or pi over 4. So we're negative in quad number 3 and quad number 4. So that tells us that x is 5 pi over 4, or it's 7 pi over 4. What we know to be 225 degrees or 315 degrees if we were in a degree mode. Here, sine's positive in quad number 1 and quad number 2. So for a 45-degree reference, that means pi over 4 or 3 pi over 4. 45 degrees or 135 degrees respectively. So there's our value. Since I'm asking from 0 to 2 pi, I'm in radian mode, but just to give us perspective, there's their values in degree mode. And because of the square root property I used, right, we have to consider both the positive route and the negative route, which actually means we have a solution in each quadrant as we moved around in one full rotation. All right, and so the square root property. In this next one, I see a 2 cosine squared and a cosine. So that tells me I've truly got a nice quadratic, ax squared plus bx plus c. We need to set it equal to 0, so I'll begin by subtracting 1. We're looking at 2 cosine squared x plus cosine of x minus 1 equals 0. So in terms of cosine, if we factor this, right, I know that the first term has to be 2 cosine and cosine, and then we need a negative 1 with a positive in here. I think this will do the trick, right? So first gives us 2 cosine squared. The outer gives us a positive 2 cosine. The inner gives us a negative cosine, so that's squared away. And then a negative times a positive is a negative, so we know we're good there. All right, and so what this basically tells us then, using the zero factor property, that 2 cosine x minus 1 is 0, or cosine x plus 1 is equal to 0. So solving this, we essentially have cosine x equals 1/2. Solving this, we have cosine equals negative 1. So cosine is equal to 1/2, positive 1/2. Well, that's quadrant number 1 and quadrant number 4. As a matter of fact, I think we did that up here. So we end up getting our x is pi over 3 and 5 pi over 3 respectively, 60 degrees or 300 degrees. Where's cosine equal to negative 1? Well, that happens at at 180 degrees, which in, dang it, why do I keep doing that? Which in radian mode is pi. All right, so we basically have pi over 3 or 5 pi over 3 or pi as our radian things, since I'm talking about radian measures. If we were talking degree mode, it would be this and this respectively. And so there you go. So again, the one thing we didn't see, I'm going to show it later, is a quadratic formula. How would I solve that? But right now, just like we follow in college algebra, we begin with something that's linear, where we add and subtract and get the trig function by itself, so we can do our trig analysis. Or, right, if we recognize that something is squared, we're dealing with a quadratic. And so if we're lucky, it factors real nice like we used to factor. We can use the square root property. If we're unlucky, we can use the quadratic formula to solve it, and then basically use my trig analysis. All right, so there's our jump start. We'll keep going through our college algebra course. You know, what happens if they're not linear or they're not quadratic? What if we throw some other things into the mix? And we'll take a look at those and solve those types of equations shortly in a new video.